our other people from them states, there are only 3 of us from Missouri, so thank you for letting us in. It really is an honor to be invited to come to a place far away and talk. And today what I want to do is tell short stories. And I was asked to cover oak and pine fire history throughout North America in a short time. And I thought, wow, that's way too much. But what I want to do is tell short stories because I think we can all learn little lessons from other places that we can consider to maybe utilize in our own management. So I want to start with giving a broad overview of fire regime characteristics. I think this builds really well on the previous presentations. Tell my short stories with data.
Hey, Mike.
Yeah.
I'm sorry, I forgot. If you can wander a bit, but you need to be closer to the podium so that the Stein room can hear you.
Okay.
My apologies for that.
This one?
Yes.
Okay. I'm gonna stand here. And then, oh yeah, hopefully this eliminates something about fire diversity in Minnesota. And so I want to start just to make sure we're all on the same page that, when we talk about fire, it's not really a thing, right? It's an actual reaction. Fire is a chemical reaction. I think we often think of it as an object. And if we start thinking of it more as a reaction, then we might approach it differently in terms of how we manage with it, or how we maybe even think about how it behaves on the landscape. It's not just a Missouri thing or a southeastern thing. It's a global process. It's going to come here whether or not we want it to, or whether or not we bring it here. And we are likely probably the most fire-dependent species on the planet. We really can't survive without cooking our food, and we all got here on a combustion reaction probably today. And I don't know how many of you have seen MODIS data. It's a satellite data of fire spots, and I just wanted to play a little bit of this. So what you're going to see here is global fire activity from 2000 to 2012, and I want you to focus here where Minnesota is, and you see kind of a pause in the movie. You see an annual kind of licking of fire from the southeast up through the lake states, spreading across the boreal zone. I'm sorry, I'm going to have to keep playing this a little bit. So just every year, it's moving from the southeast, passing through the lake states region, heading up into the boreal region. And the reason that this process is repeated every year is a response to a global chemical situation, right? It's warming, progressively headed north, and this is really a chemical reaction on a global scale. Okay. And my other major point is that I truly believe that we all suffer from some kind of sickness. It's mostly about fire. You might call it amnesia, or you might call it a divorce, but we've largely lost track. And this is Leanhout's data from the lower 48. These are millions of acres burned annually in the U.S. This is what would have been historically anywhere from just under 100 million to over 200 million annually. This is where we are here today. A 10 million acre year in the U.S. is something we get excited about and go broke in the federal government about. And then if we were to burn everything that's kind of left to burn, non-ag, non-urban areas, we would expect to be here. So if we were maintaining all the fire regimes at the historical level, we would be here, which is about an order of magnitude above where we are today. This is a fire regime concept map. How many of you have seen something like this before? So what we have here on the bottom is temporal scale. So here we have seconds and days and years, decades, centuries, millennia. And over here we have spatial scale, microsite, landscape, region, continent. Here's the fire triangle. It happens at small spatial scales and at short durations, okay? This is the actual reaction. Oxygen, heat, fuel. When that gets going, you have a fire event that's controlled by weather, landscape, and fuel. Many fire events are what we use to call fire regimes. Those are driven by climate variability, landscape features, and vegetation. And if you think about fire regimes on thousands of years, which I think is hard to do that, but we call that super fire regime, okay? That's long-term climate variations. The Holocene was talked about in the previous talk. Continental controls and biome persistence, okay? And we can actually understand fire at each of these levels. And what's amazing to me is that as humans, we can override all of this. It's an incredible power that we have as people to really influence at all levels what's going on here. So we talk a lot about fire history. We have charcoal records that kind of span this period, regions to continents, centuries to millennia. Fire scars on trees. Evan and I think we're going to both talk a lot about this, spanning regions to local scales, years to centuries. Documents, historical notes fall in this period. And then we have our experiments, our satellite data. They're all kind of contributing to different spatial scales, different temporal scales, and we can put them all together to really get a big picture about what's going on. So I just want to show you a little bit of data from different sources. These are the global fire paleo fire database of charcoal records. Hopefully you can see this is Minnesota outlined here. These little red dots are where the different charcoal records are in Minnesota. Most of them span the Holocene. I know this is hard to see, but each of these graphs are pointing to a different site, and they're showing particulate concentrations of charcoal. Fires have been at all these sites for the whole record, except for maybe here where it flatlines, and then there's one here where it flatlines. Basically, long-term presence of fire through charcoal at all these sites that are shown here. And I think that's the major take-home point, long-term fire presence. And then there may be some type of uptick in fire starting around 4,000 or 5,000 years ago. Okay, that was a very warm period. What's emerging is a large scale network of Firestar data throughout North America. This has actually just come together in the last few months, but the eastern United States is woefully lacking compared to the western United States. Some whole states have no information about historical fire regimes. And just in the last decade, this Lake States region has really come online with a lot of new data, some of it unpublished, but in the future, there's going to be a lot of really new, interesting information about fire regimes in the region. And then we have some historical reconstructions of fire regimes. This is one of the earlier ones by Cecil Frost in 1999, showing these regions here, the Prairie Peninsula, having fire frequencies somewhere 4 to 6 years. And then there's this southwest to northeast kind of lengthening of fire intervals into the Lake States area where he would project fire frequencies of anywhere 26 to 100 years. Okay, this was Cecil with his pencil doing early GIS, using his knowledge of vegetation and relationships. And he thought, it's okay, pretty coarse. This is a more recent map that I was involved in with Rich Guyette and others, Dan Day, where we have an actual mathematical equation that predicts historical fire frequency. And you can see here for this Minnesota region, a very similar trend southwest to northeast of lengthening fire intervals, anywhere from maybe 6 to 10 years, very much like what Cecil had in his previous map, upwards to 30 or 40 years. Again, this is very coarse scale. It's not taking into consideration wetlands, topography that would throw a lot of variability on here and likely lengthen some of these numbers. But you can see Minnesota actually has, common fire frequencies with other large regions throughout the country. And then lastly, this is the Landfire map for the eastern U.S., central U.S., and here you have Minnesota again, and Landfire predicting anywhere from 6 to 10 as a fire frequency for the southwestern part of the state, getting longer as you head north. Here showing much longer intervals, maybe in the 75 to 100 year period, but also showing all the fine scale variability that obviously exists out there. Again, showing what Minnesota has in common with maybe other regions in terms of fire frequency. Now that's a lot of fire that we're projecting through all these maps and kind of models, and it's almost hard to imagine in some ways. And luckily, we have the historical, kind of presence of fire still on the landscape. So really, no matter where you go in the eastern United States, you can find old fire-starter trees that go back 300, 600 years. And what these three pictures here show is that really it's no different than anywhere else on the planet. So what we do is, in terms of fire scar records, you find an old fire scarred stump, you cut a section, you mark it up, bring it back to your lab, polish it up so you can see all the cells and all the rings. You have some type of system to measure growth. Through time, you make a record of that tree's growth, wide rings, narrow rings through time, and then you have a reference chronology that either already exists or you build from living trees. You can match that pattern up with the reference chronology, date that old stump that you have no idea its ages, and then with those with that date, then mark all the fire scar years on that piece of wood to the exact year, sometimes the season of year. And then we compile that into a full record of the site. So these are different trees, they're tree numbers, and these are the periods of the time in which they span. And then each of these ticks are the fire scars on those trees. And then all these are compiled at the bottom to show all the fire scar years through time. And probably what catches you right off the bat is this isn't a regular pattern of fire. Sometimes it's very frequent, sometimes it's not. And then here's what we mostly know in our lifetime is nothing. I'm not saying you don't know nothing, sorry. But there's a whole lot of data here, a ton of data here. And this is just the fire scar data, right? There's growth data. These growth data represent climate. There's regeneration data representing forest dynamics. So we're really just starting to get kind of the cream off of the top. This is the data from the lab in Missouri. I've been lucky to work there for a little over 20 years. Rich Guyette started this collection somewhere around 150 sites in 22 states now. So what I want to do is talk about oak fire history. We're going to move from here down like this. And then I'll talk about pine fire history, and we'll go mostly around here. And this is not Netflix, sorry. This is still PowerPoint. Feel free to doze off. Here's one of the first earliest studies. This is in Southern Ontario. I think it's one of the only fire scar records in a northern red oak stand. And here they found fires occurring every 2 to 18 years prior to 1985, and go on to talk about the role of fire in maintaining this area's oak and lessening the importance of more the mesic species, which Greg Nowacki, then Mark Abrams, really put into a beautiful storyline about mesophication. But here we're talking about fairly frequent fire in oak systems. And this is some black and whites of the site. These are showing the different fire intervals here in the mid-1800s. And then, I'm sorry, these are trees regenerating, and then these are the fire intervals in the mid-1800s. So this is not going back very far, but it is definitely associating disturbance activity with the increases of oak. Here's another site in southern Ontario, basically showing that not only is there regular fire, but sometimes these are really intense fires, fairly severe fires, scarring many trees in the same year. We have these lower intensity fires, which just scarring a few trees. We have a couple of years here that are actually scarring quite a few trees. Moving down into southeastern Wisconsin, this is a study by Wolf in 2004, showing the fire frequency in this bur oak and white oak savanna. So here the record is going back to mid to early 1800s. Each of these are the fire years, showing it being more and more frequent, especially in the last 75 years. Excuse me. And again, this record may not go back into pre-settlement times. Sometimes I think we really focus on that. But here's a place that you can go observe an oak woodland with a known fire history, and actually a fairly recent fire history, and observe the effects of 12 fires in a single century at the site. So not all this data has to be about heat history. Some of it can inform our current observations. And here, Wolf also shows that most of these fires are actually dormant to fall season fires. So we're moving south. This is going to be just off the south western corner of Minnesota into the Luss Hills region, which runs along the east side of the Missouri River. The Luss Hills is the second largest Luss dune feature on the planet. And here's the Missouri River Valley here. Historically, those Luss Hills were bald. And just over the last century, wood encroachment is marching forward. And all you have are these Luss Hill prairies on the ridge lines that are very xeric. Actually, there were forests on the back sides of these. And here is what those trees would look like. And this is a very unique architecture. These are architectures that we don't actually see very often. In fact, we may not see these architectures, or our kids may not see these architectures in the future because they're likely caused by potentially crown replacing fire. It has very little apical dominance. There's no true leader. And then this tree produces a very odd architecture, whereas everything growing in around it is nice and straight. Okay, and this is the fire scarred history at this site going back to the 1680s, 1670s, coming forward to 2000. Again, this is not static fire, varies through time. Lewis and Clark lit that fire right there in 1804. They did pass right by this site, in all sincerity. Fort Leavenworth was built right across the river in that year right there. Okay, so probably associated with either more people coming, having a safe place, or a lot of conflict. Both of those things were happening. It was a safe place, and there was a lot of conflict. You can see that there's a little lag in fire here, and we actually get a little bit more regeneration starting with some of these trees into that following that frequent fire. Okay, fire frequency statistics here before 1820, every 6 years. 1820 to 1880, every 2.5 years. And then lastly, I want to move down to central Texas. This is kind of the southern tip of Burr Oaks range. Lots of oak savannas there. This is in the kind of the same fire frequency range that you would see in southwestern Minnesota. Lots of oak woodlands and savannas, but then through fire suppression, you get this mess. Okay, and so you still have your residual trees with these open grown architectures, but now they've been infilled probably in phase 2, first with eastern red cedar, and then next with China American yaupon. And what has happened now is that it's fairly impossible to reintroduce fire here without blowing the top off this thing, because it's such ladder fuel and it's such a volatile fuel. Okay, and here's the fire scar history for this site going back to the 1680s. You can see a very regular fire up to about 1850. 1850 was really the beginning of the massive cattle migration into the northern plains. We see this halt in fire across the southern Great Plains, likely due to the 6 million cows that were headed to the northern Dakotas their growing season. We did confirm that there was an absentee landowner around this period. You see fire pick up again, so you know a person's not going to be there, burn their place. That's actually fairly common. And then you see the cessation in fire here, again, corresponds with a cohort of oak being established right after that. This is an interesting site because really this woodland is a 2-age woodland. It has 320-year-old trees and 180-year-old trees. So a lot of times we think about regeneration. We need to make sure there's some regeneration here. We got to restock this place, but it may not actually even need to happen during your career. It's a 2-aged forest. So there's a lot of ecology that I think we need to know about some of these systems, and I'm sure Dana's going to talk more about that. Okay, how are we doing here? I've told 12:10.
Yeah, you see your time down here?
Oh, it's a countdown. Okay, so now we're going to do a pine tour. We're going to go from, I believe, here across this area. Again, some early work by Rich Guyette and Dan Day here in Southern Ontario, looking at fire histories in red pine, white pine stands. And we know a lot about red pine, or we're starting to know a lot about red pine in terms of fire frequency. Here they saw anywhere from 6 to 100 plus years in fire intervals with an average of 27. That's pretty long for red pine, but actually quite a few sites have that. And then what's, I think, less well studied is the fire regimes of white pine and other very long interval sites. So, I think most of the research focuses on places that burn maybe every 5 to 20 years. What's really hard to document is that 75 to 250 year interval location. And that's probably what we're talking about more with white pine. But certainly it is possible to do this kind of work with white pine. Okay, we're going to bump a little to the west. This is on Lake Superior. This is the Huron Mountains in the UP. Here we established, I believe, 5 or 6 sites here among the lakes. Actually, the Lake Superior starts right here. Very variable topography. Obviously, you have mountains, coves, very exposed sites, very sheltered sites, and then large kind of sandy outwash plain sites here near the lakeshore. And the fire histories kind of bear this out fairly well. So this is a mountaintop site, and we see relatively infrequent fire. This burned every 21 years prior to 1752, when things really start changing. And you can see it's a smattering of scars. It's not really a lined up regime. There's lots of evidence of lightning here. They still have lightning fires. And likely this is kind of a characteristic of more of a lightning small fire regime versus, you know, only like a mile and a half away. You have a very different characteristic in terms of fire regimes. You have all the events lining up, so this is, you know, higher severity fires, as well as a little bit more frequent. So the point is, within really small spatial scales, you can have a lot of variability in fire regimes. And here's the 1750s. This is really when fire frequency starts to increase here in Wisconsin, in Pennsylvania, perhaps in sites here in Minnesota. This is a regional to continental scale change in fire regimes that's likely due to settlement and exploration. This is also a very common fire-free period that's quite long, a hiatus, if you will, that is replicated across a large portion of the upper states, probably due to Native American depopulation. So certainly these records hold historical human information as well as ecological information. All right, so these are all the different sites here at this Huron Mountain region, and this is prior to 1752. The average fire interval range anywhere from 20 to up to 50 years. Bump that forward and it gets about half. Okay, we'll move over to Wisconsin. We did some work here on the Chequamegon Nicolet in two different sands landscapes. This is the northeastern sands. We have 3 sites here, 1, 2, 3, and then up here near Ashland in the northwest sands, 4th site. This one we call Moqua. It's just south of the Moqua Barrens area. And these are some of the statistics here. This is prior to 1780. These are the average fire frequencies, 9, 9, 29, 9. Okay. Here's the ranges, 2 to 35, 3 to 21. So fairly similar throughout these different sites, especially because, you know, they were all red pine generated, but fairly different sites. This is surrounded by bogs. It's like a tiny little peninsula, which is mostly surrounded by wetlands. This is now a pure oak forest that 150 years ago was red pine. So it's gone under a total type conversion, which is also fairly common. This is a mixed woodland, and this is a kind of a much rougher landscape. This slide is all about fire seasonality historically, and you know, 3 of these sites were mostly dormant late fall, spring scars. This one was 76% fall, spring, 88%, 79%. This one's actually quite different at Airport Road. It's 17%, 83% were actually spring summer. So there probably is some kind of a dominant pattern, but I think there's a lot of potential for variability in seasonality across this region. So this slide is looking at the percentage of trees scarred at these sites here in Wisconsin, as well as these sites here in the UP. All these sites are here on this graph. And the site in the UP is actually this one here. This is the Moqua site in Wisconsin, and the other sites in Wisconsin. And what this is showing you is for each year that there's a fire, what's the percentage of trees scarred through time? Okay, and usually it's fairly high, anywhere from 40 up to 90. What we're seeing is this isn't like a messy graph. These little stacks are stacked with multiple sites. So what's happening here is a lot of sites are burning in the same year, despite them being relatively far apart. And the Pine River site, despite being here in the UP, it's actually aligning with these fires that are also in central Wisconsin. And in this work, we tried to estimate fire extent. So what you see here is area burned in acres. So this would be 1 million acres burned, so 200,000 acres burned. Most fires are estimated to be 200,000 acres or less. This is drier to wetter, okay? So you see, as you get drier, you have potential, obviously, for more acres burned. But these big ones here are not slammed against the left in the extreme droughts. Part of this could be due to the climate data, sure, but there is potential for the largest fires to not necessarily be the most extreme drought years. And certainly we know this from records. Of course, here's the Manistee fire, 2.5 million acres, 1.2 million acres. And if you go by like the definition of what mega means, it's 10 to the 6th power, which is basically a million. Here you're crossing, I know this is kind of an inflammatory word, but the mega fire threshold, right? And this is real, you know, this is actually, when I come up here, this is one thing I think about is that, God, do these people know what they're living in, right? And I know some people haven't forgotten. And we went by, I think, the Hinckley fire on the way here. Certainly they haven't forgotten. It's like the back logo of the Hinckley town, you know, Chamber of Commerce. There's a flame right behind it. It looks like a flame to me. But this is very dangerous situation. And I know you all know this. So this is, I guess, just a reminder, but 1780 was a big one, right? 1780 fires in at least this area, although we have 1780 fire scars all the way down to Arkansas, but 1780 darkened the eastern seaboard. They thought actually the world was coming to an end, okay? And we wrote a paper about this in 2007. But the point is that mega fires are real, okay? Point one. And point two is that the fire regimes in this region are linked to a much larger populace. There is a potential for fire effects to link to the East Coast in this area. 1947, year Maine burned. You know, this is one of the few times that you see this word dark day. That's what it's called, the 1780 dark day. But there are other, you know, accounts in the historical record about red days and yellow days. And how many of you have seen a red day before? Someone's seen a red day? I've never even seen a red day until the Australia pictures started coming out. And so this was this past month, actually past week in Australia. This is the red day. This is what is written about for the Lake States region. This is a yellow day, okay? These are in your history. We've never seen one, but the potential is here. And then lastly, stopping at the Chippewa, this is some work that's currently underway in collaboration with the Forest Service. So here's Grand Rapids, okay? So this is a Cass Lake here. And so we have a site here at Norway Beach, and then a site over here on the Cutfoot Experimental Forest, and then some data in between. Here from 1650 to 1920, we see a average fire return interval of about 8 years. And then over here, 13.7. There are some other data in between. So there's more data coming in from just north and just south, and as well as here on the western side of Lake Winnibigoshish. And so when you add these data, the record gets pushed back another 125 years. So back into the early 1530s now with all these data. And if you look at all sites over that 400-year period, we have a fire interval for this whole region of about 9 years. And this is just kind of a fun factoid. I always like to look at Landfire. I really want to use Landfire because it's so high resolution. And I've never really tested it, but here is Norway Beach. We have our fire history site here that has a mean fire interval of 7.8 years, and then Landfire is here predicting somewhere between 16 to 30 years. So it's a little over predicted in this map in terms of what we see as a fire frequency in the last 300 years. These are those data through time for that Chippewa region. Here's 1565 going forward. Again, we see this kind of lack of fire in the 1650 era, probably depopulation, I would say, again, a signal. And then you see the picking up of fire like we see across the Lake States being represented again on the Chippewa. We actually see this picking up of fire throughout the whole eastern United States as people move in from Europe and some of this country, thus a wave of fire also across the country. Okay, so some parting thoughts. Fire has had a long presence, somewhat frequent recurrence in many oak and hard pine savanna ecosystems. And I think, 20 or 30 years ago, that statement would have been extremely controversial in some places. And maybe it is here too. I'm just an idiot from out of state, but it's becoming more and more evident as more and more evidence, or as more and more data comes in. And luckily, there's fire history to prove it, right? Otherwise, I think it would be very hard to stand on the amount of fire that was historically here. The function, composition, and extent of many fire-dependent communities are declining. We know that from especially mesofication gives us an excellent storyline for that. And, I don't know if we pay attention to this to the degree that we should, right? Because I think a lot of our solutions are mechanical and herbicide, right? There have been lots of studies that show that herbicide and mechanical treatments are not surrogates for fire, right? Fire's, effect on ecosystems is a very different spatial and very different types of effects on plants, soils, in plants and soils. Particularly plants are kind of adapted to fire, less so these treatments. Okay, so obviously there's amazing potential for understanding ecology of the Great Lakes, fire history, as well as the dynamics of vegetation and people. And I think there's a real need to kind of translate these data into some kind of hybrid of silviculture and fire management. Okay, and then historical fire regime characteristics were diverse, confirming those triangle charts that we have controls at regional scale all the way down to local scale. We have the data to show a degree of those controls at different scales. And then lastly, here humans were a primary ignition source. We still are a primary ignition source, right? We're not going to allow lightning to manage our fire landscapes. It's way too risky. The only way it's going to happen is if we do it, right? So it's been done in the past. We're likely charged with it to be done in the future. What should our role be? And I hope that's fodder for discussion in the panel. So with that, I would like to just show off the different people who fund this research. Obviously this isn't done on a shoestring, and people invest in this information, and I think it's critical to show who values that and put support behind it. Thank you very much.
All right, thank you, Mike. That was great. let's just get right to lunch. As a reminder, post your questions anytime to the link. The code for this one is FIREHIST, HIST. We'll have a panel with Evan and Mike after lunch. Again, don't rush your lunch. Eat